So hi everyone, you can see this is the experiment for to determine the wavelength of sodium light by Newton's rings. So the apparatus required for this experiment are the sodium vapor lamp, which is kept inside this wooden box, and this is the Newton's ring microscope. I am going to explain you the parts of this microscope, and here is the transformer. If you want to use the sodium vapor lamp, you must always connect it to the transformer. So directly we are not supposed to use this sodium vapor lamp. So always we have to connect it to the sodium vapor lamp transformer. Then switch on the device. Then you can see the color of the sodium source. It is always yellow. When you turn on the button, the source initially it looks like red, and after a few minutes it is going to convert it to yellow color. So you can see the color of the sodium source, it is yellow. So let us know the procedure. Before that you should know how to use the Newton's rings microscope. So first we should know how to use the Newton's ring microscope. So here is the microscope of 10x magnification. From here we can observe the Newton's ring. Okay, there are bright and dark circular rings. So here once the light passes from the single slit, falls on the convex lens. Here we have two lenses and two glass plates. So this is the lens 1, we can say convex lens. After passing from the convex lens, light falls on this glass G1. When it falls on the glass, the light get reflected towards the lens L2, that is plano convex lens, and then below that there is a glass again, that is glass 2. The light is going to be reflected. So due to reflection and refraction, the interference pattern is going to be formed, that is observed in the form of bright and dark rings, which we call them as a Newton's rings. So how to measure the diameter of the Newton's rings we should know. So here we have two scales on this microscope. Here this is the MSR, main scale reading. So the smallest division is 0.1 mm, we can say. And then here is one more scale, that is rotating scale or circular scale, which has total 100 divisions on it. So with the help of MSR and CVD, we can calculate the total reading using the least count of this microscope. This is the diagram how exactly the interference fringes are produced. So light from monochromatic source sodium lamp is allowed to fall on the convex lens through a broad slit, which enters into a nearly a parallel beam. Now it falls on a glass plate inclined at 45 degree to the vertical. Thus the parallel beam is reflected from lower surface due to the air film formed by a glass plate and a plano convex lens of large radius of curvature. Interference fringes are formed, which are observed directly from the travelling microscope. So the rings are concentrated circularly. So once we observe the Newton's rings, we have to note down the diameter of these rings by calculating or using the total reading formula, that is MSR plus CVD into least count. Here are the ring patterns, bright and dark rings we are going to observe, that is interference of the fringes. So here if we take the first ring inside, this is what the diameter of the ring. So how we can measure? We should move the, starting the experiment we have to take some precautions here. So the lenses which we are, or the glass plates, we have to thoroughly clean them, and the center of lens L2 is well illuminated by adjusting the inclination of the glass G1, that is at 45 degree. So we need to focus the eyepiece on the cross wire and move the microscope in the vertical direction. Once we get the pattern, what we have to do, we have to move the microscope in horizontal direction like this. So horizontal direction, we have to make the movement to one side of the fringes. So here are the dark and bright fringes. So one side we have to move the telescope in the horizontal direction, fix up the cross wire tangential to the ring. So we have to fix here the cross wire of the telescope to the tangential to the ring. Then we can note down here MSR and CVD. Once the cross wire of the microscope coincide to the edge of the ring, we can note down here MSR and CVD. So here the MSR, it is about this 0th of line is crossing to the around 41 of the MSR reading. Then here the circular scale reading you can note down once you adjust the ring edge. Here if how much you get, you should note down the value of circular scale reading and then multiply with the least count. You can get the total reading. So this is for right towards left side. You have to note down the another edge of the ring. So you have to move towards right side. Then you can take the difference of these two. You will get the diameter of the rings. To note down the diameter of the rings, we should move the microscope in the horizontal direction of one side of the fringes. So here is the formula to calculate the wavelength of the sodium source light. So lambda is equal to dnp square minus dn square divided by 4pr. So here dnp, diameter of the n plus pth ring, dn, diameter of the nth ring, and p is an integer of the ring. So first we should note down here observation, value of one division on the main scale, that is 1 MSR, number of divisions on the vernier scale 100. So least count of the microscope, value of one division on main scale divided by number of divisions on vernier. So 1 divided by 100 is equal to 0.01 mm. So standard value of the sodium source is 5893 angstrom. So here is the tabular column to find the diameter of the rings. So number of rings, you can start with 20, 18, 16, like even numbers you have to take. So here we have taken even numbers of the ring 8, 6, 4, 2. So then microscope reading you should note down, left microscope reading and right microscope reading. So left side MSR plus CSR, circular scale reading, then total reading you should do it by using the least count of the microscope. Then once you measure the left and right side microscope reading for the selected ring, so then you have to calculate here the dn, diameter of the ring, by subtracting the left values, right values in the left values. So then we have to calculate the diameter of the ring by subtracting these two values of left and right. So you will get the diameter and square that diameter of the rings. and then you can calculate the dn plus p minus dn square. That is you have to subtract here the value of 13.39 in the first reading. You will get 3.83. So then you have to subtract again this 9.3 in the 13. So like that you have to subtract, then you will get the difference of the diameter n plus p minus dn square. Then calculation you have to do here. So we have to find out the radius of curvature of the lens, that is r. So here we have to modify this formula. So wavelength, standard wavelength is how much? The sodium source 5893, and p is the integer. We have to calculate the p value by subtracting 4 minus 2, that is p equal to 2. So like that we have to calculate for all the rings. So first we have to calculate for r1, d4 minus d2 square divided by 4p lambda. So p is equal to 2 here. Then calculate r1, 88 centimeter. Like that you should calculate r2 and r3. So r2 you can calculate by putting the value of p equal to 2 again, that is 6 minus 4. Okay, and similarly 8 minus 6. Like that you have to do and calculate. So we have to calculate the value of r by modifying the formula. So here we have the standard wavelength 5893 angstrom. So p value we require. P value we can calculate by subtracting the rings here, 4 minus 2, and then the corresponding value of dnp square minus dn square, that is we have to take here d4 and d2. So 9.30 minus 5.15. Substitute all the values and then calculate r1. Similarly you have to calculate r2 and r3. So here you have to take p equal to 6 minus 4 and the corresponding dnp value 13.39 and dn value 9.30. You will get r2 value, that is 87 centimeter, and like that r3 8 minus 6, p equal to again 2, and the values of the diameters dnp 17.2 to 13.39 dn square. You will get the r3 81 centimeter. So take the average of all these r1, r2, r3. You will get about 85.33 centimeter. So using the first value of the difference of the square of the diameter is 3.83, you can calculate the wavelength of the sodium source. After getting the value of r, you should put in this formula dn square plus p minus dn square divided by 4p r. So p equal to 2, the integer value, and r 85.3. dnp square minus dn square is how much? 3.83. Okay, then now you will get the wavelength of the sodium source 5610 angstrom. So the standard value is how much here? 5893. You can calculate the percentage error, that is you need to subtract the experimental value 5610 divided by 593. You will get the error of about 5% for this wavelength. So that is good value. You can write the result. The main wavelength of the sodium light is 5610 angstrom.